Hello and welcome. I'm Lynn Langett. This talk is Cloud Adoption Patterns. And to get started, I want to set some context. The status of software projects is measured, and there are groups of people that publish results year over year, and it's consistently around 75%. 75% what? Well, 75% late, not on time. 75% over budget, cost too much. 75% lack key features, not useful, and or simply fail. In the time that I've been working in the industry, this really hasn't improved. In fact, I would argue in the area of cloud, it's in some cases made it worse. To contrast that, working as an independent consultant, project by project, with virtual teams, 95% of the cloud projects we've worked on have succeeded. So why and how? That's the story of this talk. To start this story, you have to understand a little bit more about me. I came out of a corporate environment, 2007 to 2011. I worked at Microsoft. When I left Microsoft, the cloud was literally launched, and I started my career in cloud. I started a consultancy that I run to this day, so it's been 11 years. And as cloud adoption has grown, the success of my consultancy has grown. And again, one of the reasons I'm giving this talk is to share information with you so that you can have success too. Now you'll notice in 2011, it doesn't say cloud focus. This is because my background is around data warehousing to be specific. So I've been in this industry for a while, and the pivot that I needed to make was from on-prem databases and data warehouses to cloud, which is probably a little bit different than some of you in the audience, but might add a dimension of interest to this talk as well. I really started working in 2012 almost exclusively with cloud data, so it's been 10 years. Now I work with AWS, GCP, and sometimes Azure and even Alibaba, but primarily AWS and GCP, again as an independent cloud architect and developer. In 2017, after having worked mostly in financial services and advertising, I pivoted to bioinformatics. And the reason for this was actually personal. A friend of mine got cancer and was not able to get personalized treatment. And some other things I learned at that time was that there was some opportunity around cloud enablement in genomics. So I pivoted, started working in 2017, and that's the place that I've been working ever since. I've had 22 clients in this period, so I've had a lot of different clients and a lot of different activities, all of them cloud-based. So why is the fact that I'm working in cloud genomics relevant to this talk? Well, I said that I have a background in data, and I've always been fascinated by helping customers solve big data problems. Well, the biggest big data problems are in genomics, by far. I had one customer that, even before the pandemic, was putting 45 terabytes per day into one of the public clouds. And, I challenge those of you who don't work in genomics, which I would assume to be most of the audience. You might think you have big data, which you probably do, but you probably don't yet have genomic scale data. So in addition to being good in terms of helping the potential for improving human health, working on cloud data genomic scale problems is also good in that it's interesting in and of itself, kind of climbing the top of the mountain and hopefully leading the way for others coming behind. Looking at the scope of my team's work over these years, I was asked recently by a customer to talk about patterns. And so that's the genesis of this talk. She asked me, have you seen patterns around adoption over the years? And I spent some time thinking about it and actually wrote a little bit about it in addition to preparing this talk. And I do see patterns, and I think that they might be helpful for some of you who are maybe earlier on your journey up the cloud mountain. The first pattern is the most important, and we're going to spend the most time on it. It's around selecting and using elastic services. Now, the other aspect of patterns is that the cloud evolves rapidly, and what was appropriate a few years ago might not be a best fit anymore. So it's kind of two different lenses. What are the patterns and over time? So another concept that I want to introduce in this talk is something familiar probably to those of you that are programmers. You've probably heard of code smells. Well, I have my own vernacular here of a cloud smell. And oftentimes my company is brought in when a cloud project is failing to help turn it around. So one of the things I've seen over and over, sort of an anti-pattern, if you will, is cloud smells. So in the world of elastic services, the most fundamental aspect of cloud is that compute should be separate from data. They need to be thought of separately, managed separately, serviced separately. And yes, your VMs, if you have them, will have some persistent disks, but that's not where the majority of the data will be. This is actually an email from a current customer who is a developer and was assuming in their cluster that's moving from on-prem to the cloud that it would operate similarly and writing all the log files to the actual VMs. Well, again, a fundamental principle is that VMs should be ephemeral. And so he was very frustrated in that he didn't have access to the log files in a way that he was used to. And again, the details don't really matter. It's more the concept of this developer wasn't yet working in a cloud native fashion, which is VMs or any type of compute, because there are other types, should come and go. And they should be used for the smallest possible time. It's almost like a light switch in your house. You turn it off when you're not in that room, for example. So like I said, when cloud was first started, this was much easier because, and this is oversimplified, but this is an architecture, typical architecture that you would build back in 2012, 10 years ago. This is Amazon. So you'd have some, VMs, some EC2 instances, some logs, some deployment, CloudFormation, and some buckets, hopefully. But even then, there was complexity moving from on-prem to the cloud that customers to this day don't properly understand. It trips them up in terms of adoption. So when you're thinking about what is elastic compute, here's what have been the significant releases around my work. Of course, EC2 and the subsequent, VMs that continue to improve. These are core primitive, and it's constant chase to keep up with all the features, even for me, who spends 25% of my time learning. In 2014, we had two significant releases. From Amazon, we had Lambda, and then from Google, we had the open sourcing of Kubernetes, which is container orchestration. And a service that I would call out because I use it constantly is in GCP Cloud Run, which is just plug in a Docker container and try it out. It's great for testing. There's other services in the realm of elastic compute, but going from appropriately selected and configured VMs to the next level of primitives, which is functions and or Kubernetes, so some type of serverless or container-based, is an area where a lot of customers struggle. So one of the things I like to offer when I give talks is not only what I see as the challenges, but also some practical things you can do. So in the case of Amazon, or you can apply this to any cloud vendor, you want to use tools. There are hundreds of different EC2 VM instances, and this is an open source tool that allows you to filter and select and look at the capabilities of your instance along with the pricing, because Amazon doesn't make that super simple, even with the pricing calculator. And this can help you. I have had so many instances where I just changed from a standard instance to a memory optimized and was able to save the customer money and get better performance, even if they were using a Kubernetes stack, but still runs on underlying VMs. So understanding how to configure the primitive is extremely important in terms of cloud adoption. So like I said, for many of you in the audience, it's probably going to be a higher number, but because I'm in the world of genomic scale data, you might be surprised that although it's important, and one of the reasons I started with compute is I do realize that most people are going to have a higher percentage of cost than this, but just to kind of see the future or where I'm working, for my customers, 95% of their cloud costs comes from data. So whether that's buckets or whether that's databases, because of the amount of data that they have. So looking at Elastic services around the data lens, I had a lot to learn there. I always say if I can learn it, anyone can learn it. I wrote books on data warehousing, kind of the old server clusters, right? And I'm not saying that for some use cases those things aren't appropriate, but they aren't appropriate at all for genomic scale data. This is an architecture me and one of my teams built in 2018. It was one of the first what's called data lakes, and this was for a genomic use case. What's important here is the results we achieved appropriately using Elastic services. The customer was running this workload on an on-prem overstressed HPC cluster and was taking 500 hours to do one genomic run. And by the time we completed the optimization, which we're kind of in the middle part of it here, we got it down to 10 minutes. This optimization got it from 500 hours to about 5 hours, which they were thrilled, but we kept going. But the point is, this is a different type of approach to this problem. You notice there's a lot of buckets here, and that's a key aspect of this. We used Elastic storage in the form of buckets rather than associated file-based storage. And, this is becoming more and more common now, but it's an area that's primitive like VMs that customers still struggle with. So Elastic Data, S3 from Amazon was the big release. Of course, we have Azure Blob Store and GCP Cloud Storage. Other significant releases, Google BigQuery, which is SQL queries on text or unstructured, semi-structured data. 2017 Spark on Kubernetes, which actually is how we further optimized that previous architecture. And I also think Athena, which is similar to BigQuery on AWS, and Redshift, which is data warehouse that can be extended to use the Redshift query engine, which is a data warehouse query engine on buckets, are most significant releases around Elastic Data in my world of cloud. And then something actually brand new is something called Data Mesh. Google just came out GA with Dataplex, which is a data aggregator for data lakes, data warehouses, and all your data services. Again, it's new, so I'm not going to go into too much detail, but it's something I'm actually working to build right now. So speaking of that, in order to build that, as the cloud evolves, again, I'm showing a lot of my actual work here because I'm thinking that that's going to add more relevance to what I'm trying to convey. Because the situation with the cloud is the vendors continue to add more services, it becomes really hard to figure out what should be used for what as an architect. So a technique that I use is using mind maps. This is a mind map tool, and this is a mind map that I drew for a customer around understanding which services are related to which other services so that we could define which areas we wanted to associate and work on. And again, this is just part of being cloud native, using the right service for the right task, and not just trying to get the same thing as you had in your current version, whether it's on-prem or a simpler version or whatever. It's understanding what is available. So speaking of understanding and storage information, I love to talk about people skipping over the basics. I mentioned that persistent disks are not a focus area. However, in some use cases, some smaller, medium business, they still are. And so even though it's not something I have to work on very much, I just go with the defaults. Again, as clouds mature, they give customers more choices, and part of successful adoption is understanding which service to pick and how to configure it. And I find often that step of how to configure it gets skipped over. The reason I find that is because somebody has a huge bill and they call me because they go with the default and they didn't need the default, for example. So Google is providing this kind of interesting format. It's called Sketch Notes, and this is showing configuration information about services. I use them all the time. I think they're fantastic. The point is, to be cloud native and cloud successful, you have to understand for whatever service you pick, which configuration options are going to be best for you, because they provide different performance and they cost a different amount. So now we're up to current, and this is a current architecture I'm working on. Again, I'm not so concerned with teaching you these architectures. If there's nothing else that you notice, you might notice there's more squares, which That's kind of the point. There's more services. Google, I know, has more than 300 different services. I think most of the major ones do. When we first started, there were like 5 or 7. So it's really challenging to keep up. And we'll talk about learning and education a little bit later in this talk, but part of the key is to understand what's available. Now, one thing I want to point out on this is, in addition to data, we have something new on the bottom right, which is machine learning. So elastic machine learning is something I think that's really poorly understood. And because I worked in fintech, ad tech, and now genomics, I've had a lot of machine learning. And so I'm probably a little bit ahead of the game. So in 2007, scikit-learn, the open source Python library, was what most people were using. Big release in 2015 was Google open sourcing TensorFlow, which is distributed partitionable neural networks that are optimized to run on their infrastructure, but they can run on others as well. And another huge release was Google Service AutoML, where you supply the labeled data, and using machine learning, Google creates for you the most optimal model. On top of that, Amazon has had SageMaker and SageMaker Labs, which is a lightweight experimental Jupyter notebook in browser, and Google has Colabs. So there's this sort of parallel environment that I find that a lot of people who don't work in machine learning but maybe have to support it are not aware of. And they think everything should just be a VM. Using the right service for the task, the best fit service, is a key aspect of cloud adoption. So the second pattern around successful cloud adoption is easier, maybe quicker to understand. So it's browser-based tools. So the cloud smell here is, how do you set up a new developer? Are you still in 2013 where you're downloading, installing, configuring, securing, monitoring, updating developer tools and libraries, spending hours, days, weeks setting up a new developer? Most people are here. Where you want to be is you want to work on the cloud, in the cloud. For example, in Google, I use the console for learning and teaching. Click on the console. I use the Cloud Shell, which is shown on the bottom, which is a VM that has all the tools associated and can connect to the Google account to develop scripts that will be used when I am deploying infrastructure. The Cloud Shell also has an editor. So if you click on the Open Editor button on the bottom, you get a full VS Code style editor with plugins. My goal is to install nothing. Honestly, it's frustrating. That's why I put it in this talk, because I see people wasting so much time trying to configure tools. And then you have users and developers that have different operating systems and different versions of operating systems and then different drivers. Just use the cloud-based tools. You're going to be so much more productive, so faster, and more secure. Google handles the keys, and things are updated. The libraries are updated. So the third cloud pattern around technology is organizational success. And again, this is, reflective of my experience as an independent consultant. It's a little bit different than if I was a full-time employee for a company. I will grant you that. But I think there's still lessons that can apply either way, whether you're a consultant or an employee. And one of these is success. Look for success. You want to popularize success, and you want to get to success. So Cloud Smell, and this one has been sort of my past couple years, people calling me going, basically a manager with a budget saying, I just found it doesn't work. My developer just quit. We missed our deadline. We missed our budget. All those things I talked about. Can you help? Can you get us unstuck? As I said, my experience with this is not just a consultant situation. 75% of software projects have challenges. Validation, making sure things actually work, is a key tenet of adoption. Well, what should work? I'm a big fan of lean. So lean methodology, which comes from manufacturing. Minimum viable anything. When I used to be back in the data warehouse days, it was a minimum viable report. Now it's minimum viable pipeline, which is usually some input, some genomic file, some genomic process, and some genomic file output. And it's been interesting in this world of very complex data pipeline processing, where it's not uncommon to have 50 or 60 or 80 or 100 different processes, to have the developers look at me like I'm a crazy person when I say I want a pipeline with one tool. But once we start working that way, and it's a fundamental aspect of software engineering, rapid feedback, it allows us to have a faster velocity and learn. So applying this to cloud, not only code, but cloud deployment all the way to the customer has been a pattern that's increased the velocity of success with my teams. So being an architect, I always have to draw things. And I love simple drawings because they communicate more effectively than a bunch of words or a spec or something. And so this is an example from a relatively recent customer where I was talking about making a minimum viable pipeline. The tasks had dependencies, so the minimum viable we ended up making, I think, was 5 tasks. But the concept is you have buckets that store some files, then you have tasks that compute on them, and then you have buckets that store the output. And you might say, well, this is absurdly simple and ridiculous. I'll just give you an example of something I've been working on this year. I called to a project that was stalled for 2 years. Nothing ran. We got it running, this version of it, in a month. And we're probably going to go to production in another month because you need to have a starting point. So the first 3 patterns were around technology. The next patterns are around people because for success in software, you have patterns around working with people because people make software. And the first pattern is technical manager. Now, what I mean by this is understanding your responsibility as a team member to support, enable, and develop a technical manager. Because oftentimes people come to management because they have management skills or they have software skills and not management skills. They usually don't have both, especially mid to lower level managers. This is from an article, and it's another client recently. Common when you're moving from on-prem to cloud. And genomics is coming kind of slowly, certain areas, clinical genomics, hospital-based genomics, because hospitals, of course, are very conservative, as they should be, so they still have even data centers. This, in other domains, I haven't dealt with this for 10 years or so. When you're coming from non-cloud to cloud, this is a particular challenge. And now, because of the development of cloud services, this writer, Lee Atkinson, is talking about if you simply lift and shift, you're generally going to have a higher bill, which I've gotten many a contract because of this, where developers weren't cloud fluent and, some startup or some new implementation went to production and 6 months later, the cloud bill was just out of this world. So what are the 5 habits of technical managers? The first is managers should be involved in actual updates and they should be listening more than they're talking. So again, if you don't have the manager actually getting some sort of in-person update, then you want to set that up. You want to help the manager with clarifying questions. If they're not familiar with the technology, you want to serve as a translator so that the developers can communicate in a way the manager can understand. You want to identify key users as well as stakeholders and involve them. So kind of a 360. So who are some users who we could actually get the software in the hands of? And what are the stakeholders looking at from an organizational perspective? This includes budget. And then you want to look at what software is deployed. And again, I define deployed as deployed to end users actually serving them, not in testing, not in developers' desktop, actually deployed. This is the one that I've had lots of times where when I ask that hard question, it's actually 0. And, it hasn't been openly discussed. So this is challenging, but it's really important that you get a baseline for reality. Managers should participate in technical training because the more they can understand, the better they can be in terms of what they're doing. So a technique to communicate with managers, and I pulled this from my world of business intelligence, is to make a KPI-based dashboard for the status of, in this case, a cloud deployment. So again, it doesn't really matter that you read everything across the top. What's important is what I've done is I've framed my communication in a way that the manager can quickly interpret and action. You can see, for example, the 2 red X's, that would be something to escalate. The things with checks, that would be something to celebrate. And then you can also look across and you can see that the DNA pipeline has more challenges than the RNA pipeline. This red, yellow, green technique is something that I have done with basically almost every client, and it really, really helps with communication. And there's this theme of draw a picture, because if you have a simplified diagram or a picture, then you can align along goals. You can bet that everybody here wants to get those X's off, for example. I've mentioned it already, but I really can't mention it enough, that the fifth cloud pattern is end user focus. Once again, from a recent client, it took me a couple of months to actually get them to turn on their cameras. And I understand about when people have little kids at home and stuff like that, so they need to have their cameras off. When it's one meeting after another with all the cameras off, that is definitely a cloud smell. Initially, you want to ask to meet people in smaller groups and get to know them a little bit more about their work. And that's really a 360, the developers, the infrastructure people, the end users. And that's a tip basically to get around this kind of cloud smell, if you will. So what you want to get to is very small groups. You want to build with the users. So you want to identify the MVP, what's the most important, in my case, task or tasks in the pipeline. And then you want to explain how you're going to build this MVP. And then you want to work side by side with them so that you can understand what they do now, so that you can streamline the process for installation, for testing, and for running, to make it as close to what they do now, or if it's different, to explain to them the reason why. In my case, it's because they are working with constrained storage and they're going to move to virtually unconstrained storage. And as soon as I explain that simple thing, I have a waiting list of users that want to work with me in a situation where there was zero adoption previously. So the third people-focused cloud pattern is learning culture, and I picked Ladder specifically. As you may know, in addition to implementing and building things, I have a number of education resources. Most are free, but I also have around 30 courses on LinkedIn Learning, and I've created customized courseware for customers for years. So it's a 50% building, 50% learning. In fact, I base my consultancy on that. And I also model it, spending 25% of my own personal time learning. And I consider that ongoing requirement to be a successful cloud architect. And I also, anyone I hire, I actually hire people and pay them to learn with me. So that's how strongly I'm committed to this. And that's reflective of learning culture. This was written just actually recently, and I thought, oh, this just fits right in with my talk, so I would include it. Cloud smell is, we'll just figure it out. We don't need to spend any time learning. Wow, it's a huge anti-pattern, and it results in all those 75% problems that I talked about. So Lydia Leong, who's the lead analyst at Gartner, wrote this cloud adoption will fail because of the skills gap. And basically it's saying what I'm saying, which is as there's more and more services, 300 or so, it's not optional. You have to take this approach that I've taken for myself and my subcontractors. You have to allocate, and I would say about 25% of your time to learn. That's part of your job. And she says, my colleagues and I have previously written that cloud skills gap has reached a crisis level. And I would say it has. So that was a little crazy, wasn't it? Well, that's the way it really goes. There is this concept of sort of just-in-time learning where, we think we're going to learn security. Nope, we're not ready. The only thing that is a constant in my experience with teaching yourself and teaching others cloud-native concepts and services and architectures is the bottom, basics, optimization, and automation. Things will pop in and pop out and move around, and you got to be very flexible. It's not linear. It's not like learning, math or grammar or something. It's as needed along those three lenses. It's much more sophisticated because you can't expect people to learn all 300 services. They don't need to. They need to learn around the primitives. How am I going to implement compute? How am I going to implement data? How am I going to implement security? Not, do I know every single compute service on all of the clouds? Don't need to, right? So where do people learn? again, this is a big challenge, especially in enterprises. This is something I'm working on with a current client. Enterprises have to have some security controls. And sometimes, in the case of health, they have quite restrictive, really, really be concerned for the data. So how do you create an environment that has enough flexibility that people can learn, but still abide by the organizational rules? So one of the challenges that this organization has had is the tutorials for most cloud vendors are written as if, you have admin on everything. And that is just not realistic. And so they've had a sort of a history of challenges with the out-of-the-box training. So one of the things that we're thinking about is how to take some of the current challenges and to create a sandbox. And to that end, this is, again, from work that I'm actually working on right now, where this new concept of a data mesh is something that I need to become more fluent in. And it looks like it could be a good fit for this particular organization's needs. So what I'm trying to figure out is how to build a sandbox, and what that means in this case is a GCP project, where a subset of services would be made available with certain restrictions on them. Because, of course, it's genomics. And, I always like to tell this story. I had one client, when they learned about BigQuery, they got really excited, and one analyst ran one query the next day that cost $83,000. Of course, that customer had a good relationship with Google, so they have to pay that. But you have to put up guardrails, even if you don't have data security, because we're talking about very powerful services here. So this idea of safely is both around data security and cost. So I've presented the key patterns that I've observed over my 11 years of working in cloud. And I'm hoping that you take away 1 or 2 or 5 or all of them, and they'll help you to have successful projects. If you take away nothing else, please understand my focus on working with users. Like I said, because of the personal situation, I pivoted to supporting cancer research and gotten a lot involved in COVID research actually too. And my people that I work for, yes, I have clients who pay me and all that, but it's my doctors and my genomic researchers and my genomic analysts. And that's who I get up in the morning for, and that's who I do the extra work learning all the new services for. And that's who I talk to and serve. Think about that and make that a key component of whichever of the patterns you adapt. So the patterns together are represented here. And I have a link to the article that I wrote that's similar but not the same as this talk on Medium if you want more information, and I'll make the slides available. And to learning, I have a high-level repo on GitHub. There it is. And I have 100 resources that are mostly free. So it's a record of my journey, if you will. And I welcome your use of it. It's free, and your contributions. So I wish you much success. Thanks for taking the time to listen. I'm Lynn Langit.